The universe is much larger than anything humans could possibly imagine. Over the past decade, there have been fascinating discoveries of new worlds. Just this year, NASA confirmed the discovery of more than 5,000 exoplanets, or extrasolar planets. These range from super-Earths to gas giants like Jupiter, to ice giants like Neptune, and other distant planets. Although planetary scientists have found many of these odd locales, it's believed that our Milky Way galaxy alone has more than 1 trillion exoplanets. Now, let's demonstrate how researchers recently discovered a planet so enormous that it easily dwarfs the size of our closest neighbor. What is this massive superplanet, and what exactly do we know about it? Let's find out. The planet known as B Centauri b, or B Centauri ABB after its discovery, has challenged the knowledge of astronomers and scientists alike. This large planet lies in an environment that was previously thought to be too hostile for a planet to develop around a massive pair of extremely hot stars. According to the European Southern Observatory, which captured images of the planet from its very large telescope in the Chilean desert, no planets had previously been discovered around a star more than 3 times the size of the Sun until B Centauri b. As one of the most massive planets ever found, B Centauri b is an exoplanet existing outside our solar system and is 10 times as massive as Jupiter. Mark Janssen, an astronomy professor at Stockholm University and the study's principal investigator, stated that this discovery completely changes the picture of massive stars as planet hosts. The highly large and hot B-type twin star in the Centaurus constellation is at the core of this solar system. It produces a significant amount of high-energy ultraviolet and X-ray radiation, which strongly impacts the surrounding atmosphere and should work against planet formation. It was once thought that it would be incredibly difficult for big planets to develop around B-type stars, as they are believed to be quite corrosive and harmful. In this harsh environment governed by intense radiation, everything is on a massive scale. The stars are bigger, the planet is bigger, and even the distances are bigger. According to research, the findings demonstrate that planets can exist in star systems far more massive than previously predicted. B Centauri b has one of the broadest orbits ever found, measuring 100 times farther than the separation between Jupiter and the Sun. The planet's survival likely depends on its great distance from the pair of core stars. Janssen predicted that there would be a general increase in the amount of time spent searching for planets around high-mass stars, both for the sake of finding them and defining them in order to determine more precisely how they may have formed. While we wait for more discoveries, let's look at another massive planet that is 9 times the size of Jupiter and is forming in a violent way. In general, cooking a meal can be compared to how planets form in our universe. Both the ingredients and the cooking procedure used to create a planet are subject to change. A planet was observed by scientists using the Hubble Space Telescope as it underwent disk instability, a violent and dramatic event that has been compared to a flash fry. In this approach, the protoplanetary disk orbiting a star collapses and is broken up into one or more planet mass fragments by gravity, rather than developing into a planet over time from a small core that gathers matter and gas. Hubble's resolution and lifespan proved to be a crucial missing piece in the puzzle, as astronomers have sought definitive proof of this process as a likely candidate in the formation of Jupiter-like planets. The young star, thought to be only 2 million years old, is surrounded by a protoplanetary disk of dust and gas with a distinct spiral structure swirling around it. This is the location of the newly formed planet that roughly corresponds to the time during planet formation in our solar system. At this time, the solar system is 4.6 billion years old. The study's principal author, Fane Curry of the Subaru Telescope and Eureka Scientific, said, "Nature is clever. It can produce planets in a range of different ways. The raw materials for every planet came from a circumstellar disk. The predominant idea for the formation of Jupiter's planet is known as core accretion, a bottom-up method in which planets trapped in the disk develop from tiny debris that circles a star and then collide and clump together to produce larger objects. Gas from the disk is then gradually accumulated into this core. The disk instability approach, in contrast, is a top-down model in which gravity causes a huge disk surrounding a star to quickly shatter into one or more planet mass fragments. As the disk cools, the newly formed planet known as AB Origin b orbits its host star at an incredible distance of 8.6 billion miles, which is more than 2 times farther than Pluto is from the Sun. It is most likely about 9 times more massive than Jupiter. It would take a very long time for a planet the size of Jupiter to develop at that distance. This leads scientists to conclude that this planet could not have formed at such a great distance without the disk instability. It also stands in stark contrast to what the generally recognized core accretion hypotheses predict for planet formation. The near-infrared camera and multi-object spectrograph and space telescope imaging spectrograph data are combined in the new analysis. This data was compared to those obtained by the cutting-edge SCXAO planet imaging instrument on Japan's 8.2M Subaru telescope, which is perched atop Mauna Kea in Hawaii. Given how difficult it is to distinguish complicated disk features unrelated to planets from complex disk features related to young planets, the amount of data from space and ground-based telescopes proved crucial. It is very difficult to interpret this system, according to Curry. This is just one of the reasons Hubble was necessary for the project. A clear image made it easier to distinguish between the light coming from the disk and any planets. The huge disk of dust and gas swirling around the star AB Origin is angled nearly face-on to our perspective from Earth, which was made possible by nature itself, Curry underlined. Hubble's endurance was vital in assisting scientists in determining the protoplanet's orbit. At first, he had serious doubts that AB Origin B was a planet. The Hubble archive data and the imagery from Subaru were crucial in causing him to change his view. According to Curry, we could not detect this motion for about a year or two, but Hubble provided a time baseline combined with Subaru data of 13 years, which was sufficient to be able to detect orbital motion. Olivia Guan of the University of Arizona in Tucson and Subaru Telescope in Hawaii claims that this result makes use of both ground and space-based observations and allows for the use of Hubble archive data to travel in time. Now that AB Origin B has been examined at several wavelengths, a dependable picture has developed. This new finding provides compelling evidence that some gas giant planets can originate via disk instability mechanisms. Gravity is ultimately all that matters since, one way or another, the byproducts of star creation will be drawn together by gravity to create planets. Astronomers can better understand the evolution of our own solar system by comprehending the early stages of the development of Jupiter-like planets. Future investigations into the chemistry of protoplanetary disks like AB Origin will be made possible by this discovery, particularly those using NASA's James Webb Space Telescope. On the other hand, the Transiting Exoplanet Survey Satellite, TESS, a NASA mission, has discovered a bustling neighborhood just 33 light-years from Earth. It has a star in the center, a few planets orbiting that star, and at least 2 terrestrial, Earth-sized worlds, according to the scientists who made the discovery. It would take you roughly 330 years to reach this solar system-like region of the galaxy if you could move at 1/10 of the speed of light. That is obviously not feasible for a number of reasons. However, we can draw a very accurate picture of this neighborhood by utilizing specialized Earthborne tools like telescopes and spaceborne spectrometers, possibly even the James Webb Space Telescope once it's fully operational. The host star of the system, designated HD 26965, is a relatively tiny, so-called M-dwarf. According to what we now know, M-dwarfs are 10 times more prevalent in the cosmos than our Sun, a G-type main sequence star, although being 10 times less massive. The inner planet, which is about 1.2 times larger and twice as massive as Earth, revolves around its star every 2.8 Earth days. The other alien world, which is 1.5 times larger and 3 times more massive than Earth, orbits at a distance of 5.7 Earth days. Both are regarded as rocky given the brightness of their star. Both of the planets in this system are among the greatest candidates for atmosphere research, according to Michelle Kunimoto of MIT's Kavli Institute for Astrophysics and Space Research, one of the discovery's main scientists. This comprises investigations that seek to respond to questions like, is there a volatile-rich atmosphere around these planets? Are there signs of water or carbon-based species? In other words, is there a protective layer similar to the ozone layer on Earth and living things similar to humans? According to Kunimoto, these planets are fantastic test beds for those explorations. However, before you get too excited, scientists underlined that the recently discovered rocky worlds of interest are probably not habitable because they are likely too hot to support water and are located extremely close to their host star. According to the study, the core planet heats up to an estimated 880 degrees Fahrenheit. In comparison, The outer world maintains a temperature of about 548 degrees Fahrenheit. Don't you consider that range outside the habitable zone? However, if you think you can cope with that extreme temperature, we won't stop you. Nevertheless, the search for habitable exoplanets could benefit greatly from learning more about these worlds. In other words, they might guide future research into the possibility of discovering planets in the habitable zone. Since its launch in 2018, NASA's TESS has been slowly finding exoplanets throughout the universe and has already compiled an incredible catalog of these distant planets. It basically operates by looking for recurring dips in the luminosity of stars throughout the universe, as these fluctuations in light could indicate the passage of a planet in front of those stars. Consider looking at a lamp while someone passes by it to block your view, even while you might not be able to determine who specifically blocked your view if you were very far away from the lamp. You might assume that someone did so because the light clearly went out for a little period. That is somewhat how it is with TESS. While keeping an eye on the satellite's incoming data, Kunimoto discovered one of these dips. They were traveling from HD 26965, the star. The researchers concluded that there are indeed 2 planets orbiting the star in question after conducting a number of additional tests, one of which is the well-known gravitational wobble test, which examines whether the light dips are accompanied by some gravitational pull on the star itself. There are numerous multi-planet systems with 5 or 6 planets, particularly in the vicinity of tiny stars like this one. Hopefully, we'll discover more, and if we do, perhaps one of them would be in the zone where humans can live. Optimistic thinking, right? TOI 849b, an oddball among wild things on the scale of our galaxy, is a totally weird planet that circles a sun-like star from 730 light-years away. The planet is unlike anything astronomers have ever seen, either in our own solar system or from afar. It is large, dense, and tightly bound to its home star, with up to 40 Earths' worth of material squeezed inside. The roasting world of TOI 849b is the largest rocky planet yet seen. Strangely, despite having essentially little atmosphere, TOI 849b's enormous weight suggests that it should be a massive gaseous globe like Jupiter. It is difficult to explain how such a world came into existence given what is known about how planets grow. A planet as large and dense as TOI 849b is extremely difficult to create without turning into a gas giant. Something went wrong during that routine procedure. Instead, according to experts, the planet is the exposed, airless core of a giant planet that should have outgrown Jupiter. Planet searchers have discovered thousands of distant planets within the star fields of the galaxy over the past 10 years. The majority are undoubtedly extraterrestrial, falling into categories like super-Earths, rocky planets larger than ours but less than Neptune, or hot Jupiters, large gaseous planets in close orbits. But TOI 849b defies categorization. This world was also discovered by NASA's Transiting Exoplanet Survey satellite, TESS, which is scouring 200,000 of the nearest, brightest stars for extraterrestrial life. A sliver of starlight was briefly obscured by the planet as it crossed the face of its star, revealing its presence. These ephemeral, gloomy transits showed that an alien world revolves around its star every 18 hours, which means that its surface is swelteringly hot at 2,800 degrees Fahrenheit. Additionally, test measurements reveal that the planet is 3.5 times as broad as Earth or 85% as wide as Neptune, making it an unusually large planet for one that is so close to its star. With the HARPS instrument at the La Silla Observatory in Chile, additional studies of the host star's gravitational wobble revealed that, while TOI 849b is roughly as wide as Neptune, it is at least twice as massive. TOI 849b is very dense given its size. The rocky planet may have a thin layer of atmosphere that is likely made of hydrogen and helium, but it does not contain nearly as much gas as a planet that size should because of its peculiar characteristics. It is likely the core of a gas giant planet, which should have become more massive than Jupiter according to current theories of planet formation. Planets develop from tiny seeds of rock and ice sown in the whirling disks of gas and dust that surround young stars. While some planets like Earth accumulate a tiny amount of material and remain small, others like Jupiter and Saturn gather gas and expand into inflated worlds with enormous atmospheres. When a planet reaches a mass of around 10 Earth masses, a process known as runaway gas accretion starts, and the planet's gravity quickly pulls in nearby hydrogen and helium. It stands to reason that a seed with 40 Earth masses should have accumulated an incredible amount of gas. Yet TOI 849b does not appear to have done so. We already know that planets like TOI 849b are uncommon, but that doesn't mean they don't exist. We just need to figure out how and why.